Assalamualaikum and good day. Today I'm going to speak to you about my study, which is the simulation process behind the numerical study of micro-milling process using finite element method. So a little bit introduction on what is micro and milling process. Micro machining is a process of producing miniature product and components with features that range from 10 of micrometers to a few millimeters in size by removing the unwanted material from the workpiece using the mechanical force of micro tool. The mechanical micromachining is basically not a downscale of the tool size and the material removal from macro milling. There is a point of limitation on the scale down procedure. Unlike macromachining, micromachining must take in essential factors of the cutting tool edge geometry, tool offset and run out, tool deflection, vibrations, material microstructure, thermal expansion, tool rigidity and stiffness. These factors completely change on the interaction between tool and workpiece in micro scale that make the machining process considerably hard to pursue. There are general characteristics of the micro and milling cannot be changed to some significant constraint by downscaling the machining process from the conventional macro and milling, which are first one is tool radius, second one minimum chip thickness, and the last one is size effect. Okay, for the tool edge radius, the assumption which is normally used in macro scale cutting is that the cutting edge is considered sharp. Okay, no tool chip contact along the clearance face. This chip is formed by the mechanical shearing force due to the interaction between sharp tool and the workpiece. However, this assumption fails to apply in micro scale cutting due to the size of the cutting edge radius that becomes significantly larger compared to the chip thickness. Therefore, assuming that the cutting edge is considered sharp is not valid in micro scale cutting. Since the sharp cutting edge model assumption failed to explain the material removal at micro scale, the round cutting edge model takes into account for the minimum chip thickness, the micro milling process are greatly affected by the ratio of the feed to the tool cutting edge radius. The edge radius of the tool tends to be considered as the same order of magnitude as the chip thickness. Therefore, slightly change in the low depth of cut will slightly significantly influence the cutting process. The active material removal mechanism is defined predominantly by this ratio, okay, which determines the resulting quality and surface roughness. Okay, and lastly, the size effect is the high specific energy that required to remove a unit amount of material due to the small uncut chip thickness. Okay, there are several responses which are used to evaluate the process performance in micro and milling. Among them, for example, like cutting force, cutting temperature, stress, strain rates, tool wear, surface roughness, and burr formation. All these process performance are generally developed with an advanced predictive model. This model can be broadly gathered as analytical, numerical, and experimental technique. In numerical simulation using FEM has emerged a powerful tool to study the micro milling process, which is more cost effectively and efficiently. Finite element analysis can provide detailed insight into stress, strain, temperature distribution during micro milling, which are crucial for the process optimization and development of predictive model. Okay, therefore, understanding the force acting on the cutting tool design and estimating power requirement plays an important role in micro milling process. Okay, this study was conducted with three major works consists of FE model development, FE model validation, and FE proposed model. At the initial stage of the of this research, the initial FE model was developed by referring to the existing model in the literature as the first step to get a validate model before the actual simulation analysis take place. The micromilling model was simulated in using Abacus software. Okay, the simulation results obtained necessity as precise as possible for the investigation of cutting force prediction in micro and milling. This can derive to model validation. After the initial model has been validated, the different test cases which have the same parameter used in the experimental literature approaching to use the micro and milling of ASID2 still were used. Okay, from the figure here, number 2, the errors between the simulation and reference result are acceptable in consideration of the effects of the machine tool vibration and also the simulation accuracy. Where we can see here a good agreement can be observed, therefore there will be lead to successful of simulation results and objective of this study. Okay, after the initial model was validated, the actual simulation will perform. Okay, the simulation work was developed according to the simulation work configuration shown in this slide. Okay, the workpiece material used in this model was hardened ASID2 cold world tool steel, and the Johnson-Cook constitutive equation was employed to the model. Okay, the micro tool used in this model had a nominal diameter of 0.5 millimeter. Details of the tool edge, radius, number of fluid, rate angle, helix angle are listed in the table. The cutting tool was modeled to be deformable and was divided into different wear levels which represents the tool edge radius in order to predict the tool wear during the operation. Okay, for the cutting parameter over here, the table shows that the feet per tooth, the depth of cut, the cutting speed, and also the tool rotation used in this study. The test conducted using low level and high level cutting parameter with different type of wear levels of the cutting tools to see the comparison. All these parameters were obtained from the previous experimental work study done by Saidon et al. On the micro and milling of ASID2. Still, the same cutting parameters was used in order to confirm the cutting force model developed by FEM in this study is capable to predict the cutting force closely to the experimental results done. Okay, the simulation was carried out on the extended material workpiece of 20 millimeters in order to investigate the cutting force during new tool, which is the initial cutting, and the worn tool condition during the final cutting. The 3D model setup of micro and milling was developed where the cutting tool rotated around the z-axis and the workpiece fit in the cutting direction in x-axis at the same time. For the result and discussion, we will discuss first on the cutting force. Okay, figure shown here, the cutting force components, which is Fx, Fy, and Fc obtained from the simulation of test 1 and test 2 during initial cutting and final cutting respectively. It can be observed that the force component increased as the cutting progressed up to final cutting, which is 20 millimeters cutting length. The feed force, which is Fx, and the normal force, which is Fy, showed similar magnitude while the thrust force Fz was generally lower during initial cutting. As the machining reached at the final cutting, all force components increased significantly with Fz have the same magnitude with Fx and Fy. The reason why the cutting force increases as the cutting length proceeds is based on the fact that there was further deformation energy is required during the chip formation. This can contribute to the size effect by modifying the chip formation at the tool tip, and rubbing process would occur rather than cutting process. So fundamentally, as the cutting progresses, all force components increase significantly due to the tool wear, and this leads to the tool deflection, tool breakage of damaging the workpiece or machine surface. Cutting tool greatly wears at the tool tip. Thus, it will be the first point that categorized as wear criteria. This is due to the fact that the tool tip is subject to the highest contact pressure compared to the other parts of cutting tool. For micromilling, it could be claimed that the wear at the tool tip determines the tool deflection and also the tool life. Okay, since the critical points of the tool wear is the tool tip, is at the tool tip, the tool wear effects were recommended. Okay, for the tool wear effect in micromilling, investigation of the tool wear effects in this FA model was conducted in order to demonstrate the actual condition of micro and milling when cutting progress at several lengths. Okay, the cutting components force Fx, Fy, and Fc obtained from the simulation shown in figure, it can be seen that all force components increase with the increasing of tool edge radius. This point towards that cutting with a worn tool, which represents 6 micrometer and 12 micrometer, generates a higher cutting force compared to the unworn cutting tool, which is 3 micrometers. This might be due to the increasing rake angle provided by the increasing edge radius. The more negative rake angle through a wide and expand plastic shear zone, the higher energy and cutting force obtained. The increase in the cutting force can easily lead to a tool deflection, tool breakage, or damaging the workpiece and also the machine surface. Okay, this was the same as what occurred in the real machining process, where the contact temperature is leading the factor to of the tool wear at the cutting zone. It can be seen that the temperature distribution contour was not located at the tool tip, but stay above it, and also can be detected near rake angle at the tool rather than the flank face of the tool, as shown in these three figures. Okay, that is because the friction between tip on the rake face is more than the friction cutting tool workpiece. Large edge radius promotes a higher temperature due to more deformation on the material. It shows that the rising of the temperature along the cutting edge as the tool cuts through the workpiece may lead to a conclusion that the wear increases as the edge radius increases. Right, the results of this study were analyzed in terms of cutting force and also the tool wear. The following conclusions were made based on the objective of the study that has been successfully carried out in the simulation work of micromilling of ASID2 steel. Okay, for the cutting force, the result demonstrated that as the cutting progressed, all the cutting force components increased. The feed force Fx was a large increase compared to the thrust force Fz and the normal force Fy. For the wear, to wear is that the wear development of the micro and mill can be described with the increasing of tool edge radius. This can change. This can significantly affect the cutting force generation, and this can also be attributed to the fact that the cutting force increase alongside cutting length due to the tool wear development. If you have any questions, you can directly email through this email address. And that's all for now. Thank you for listening.